Welcome to Module 25, Deep Neural Network, Convolutional Neural Network Imaging Classification. In this module, we're going to learn the convolutional neural network applied for imaging classification, and we're going to use the pump bearing vibration remain useful life classification. So based on the imaging of the different level of vibrations that is plotted based on our prognostic health management program, defining an interval setup that the image is plotted and classified, we will be able to have the classification of moderate or critical level of vibration based on the picture that's taken from our prediction. As usual, we have different concept of applied to artificial intelligence, such as artificial intelligence, machine learning, unsupervised machine learning, supervised machine learning, classification, and supervised machine learning regression. However, now we're going to look on deep machine learning that have a quite different approach and consider in our specific case the convolutional neural network. So concerning the different types and methodologies that we have in artificial intelligence, now we are focused on deep learning. As we saw, the general concept of machine learning is to, since you have a data set, we split this data set and train data and test data 70-30%. We get random samples from our data sets to create our training data. And then, based on a predefined model, we use the training data set to train the model. Then we verify the error, and the further step is to test and verify this model based on the test data sets. That are 30% of random samples that were selected from our data set. If the error is acceptable, we go to the next step, that is apply a new data set in our model, and then if the error or accuracy is satisfied, it is good, we validate the model. Let's remember the neural network because it's a very important concept that will be applied to convolutional neural network. So a neural network as a beginning mimics the human neurons that pass relevant information for each other. So basically we have a very simple configuration of a neural network that we have the input layer and the output layer. So basically between the input and each output we have waves, and then we have an output functions that will be equal to the product of the input vector value here multiplied for wave plus this input value of this vector multiplied for the wave plus this input vector multiplied for the wave plus this input vector multiplied for the waves. When you have different, more complex configuration, we have a class. It depends of our problem. As we already saw, we can have a classification and regression. So in the end, we have an output function here after this layer here that will produce an output. This is a very simple case that we always only put the output. But however, we can have a neural network that have the input layer, hidden layer, and output layer. In this case, this output is similar to what we have here, but in the end we have also the other the classification, the final layer here, and this final output layer will come out with our classification, classify the input information that was set in here as one class or in another class, or even will come out with a regression values for a function, as we already saw. The deep neural network, the difference from a normal network, that you can see have a lot of hidden layers class, and that's of course by the one hand that will increase the accuracy of your model, by the other hand that require more time and more for simulation and a more let's say robust algorithmic computer to run such simulation. This concept is also applied in what we have as a convolutional neural network. The convolutional neural network you come out with image input. Then the image go through different layers, and such as convolutional, pooling, and ReLU. The objective of these layers is to split this first image in different matrix regions, and then intensify the characteristic of this each part of the picture, and then in the end such information will be defined as a vector here, input for, let's say, a complex network, as we saw here, that will in the end give an output, and this output go to a classification function such as softmax that will give the classification based on probability of the two classes that you want to classify our first input. So the general process is, first we need to train our convolutional neural network with a set of images, and after that I will starting to input image and get this classification. So the convolutional neural network can also be applied not only for define the critical levels of degradation based on pictures of, for example, the plot of the RMS vibration, or even infrared test pictures or radiography tests to classify equipment, but we can also classify equipment when in defected and non-defected. Okay, so basically in a process line we can have a camera that take pictures of some equipment, and based on this picture, so here a radiography picture, we can see the one that is the defected. And then of course by applying the convolutional neural network based in the previous process that I explained here, we put these two images here, training the model, and then we put actually a lot of images first to train the model. Then we come out with image concerning the same, let's say, the same object of the study. So in this case here we have these two these components, and I want to classify as okay, not okay, defected and not defected. Then I use the neural network to classify such equipment. So that's have different application, even sounds. If I have the waves plotted in a graph, I can classify the image, the sounds. So convolutional neural network have many applications and based on an image classification, and that's the general principle. And in our case, since our object of this training is maintenance, we focus on a maintenance case that we want to classify when an equipment pumper bearing achieve a high level of vibration. So that means for every set of time, let's say every 5 hours or 6 hours, you have a plot of the vibration in a bearing, and then based on this picture of this plot, the vibration will be classified as moderate or critical. And then if it's critical, we'll set up a visual alarm in your asset intelligence management system that will enable the maintenance professional to check it out and look upon this type of a problem. And then that's the main advance to have artificial intelligence, and that will be able to transform your asset management system in asset management intelligence system. That means the system by itself collect information and collecting data and give you valuable information for you to take your decision, and reduce a lot of time of maintenance professionals in discussion and collecting data and so on. Okay, so the first step is the input data image, and we need to understand how the computer see the image. So the convolutional layer aims to perform the reduction of the picture size represented by the inputs of a matrix. So each picture is represented for a matrix. And then of course the first layer, that is a convolution layer, we use a filter that's also a matrix. So basically what the algorithms are doing, they got a picture Then they split this picture and represent this picture in matrix. And then, of course, matrix with numbers of 0, 1, or other numbers. And the highest numbers are the dark parts of the picture. Then, based on it, they will select the picture. They will learning about this picture and how to classify this picture. That's the general concept. So, what we call each filter. So, as I mentioned, each filter can be thought of a feature identifier. So the filter will identify one specific part of the matrix of the picture, and then of course we can classify the image. So here is how we represent a image when they have a color. So when an image have a color, usually we use what we call red, green, and blue. What's defined 3 matrix, so the representation MN3, and then when it's black and white is just MN. Okay, so that's basically we have a matrix that represents the characteristic of this picture, and based on this characteristic, what the convolutional neural network is trying to classify parts of this picture. So we can see the transformation of the main picture along the different layers, such as convolutional layer, ReLU, and so on. And then in the end, this algorithm will learning how to classify a new picture when come out, if it is number 2 or number 3 or number 4, or in a more complex case, whatever picture that we define and train the model to classify. Okay, so in our case here, what is applied to maintenance, we are training our model with different profiles of vibration. So we can see here that is below the 4 RMS is considered normal vibration. Higher that is considered higher. After 6, let's say 6, above 6 we consider high. Between 4 and 6 is considered moderate. So we have different profiles. So what we want to do is first training the convolutional neural network with different profiles of vibration pictures, and then of course let's take a look on this first picture here. So after that, let's say that we have we training our model. Now we want to classify the different level of vibration. So in this first case, when we are achieving this point, if I took a picture in this interval of time, this bearing vibration needs to be classified as moderate because it's between 4 and 6, and then after 6 hours then also be classified as moderates. And here then the next 6 hours they will also achieve the critical level because it's higher than 6 the value of RMS, and then when they have this region, this level higher than 6, this vibration will be classified as critical, and then based on it, this information will be sent a visual alarm in our asset management solution. Then the maintenance expert will be able to capture this information, and then since you work in a single asset management system, you will be able to open working order to update your plan, to update the criticality of each equipment, and everyone will have the access. We'll speak later on about asset management intelligence, but we need to understand how this process all occur and how is the process of artificial intelligence behind of all this information. We need to, and then our focus here is to demonstrate the convolutional neural network for image classification. Then, of course, as I mentioned, we will have a picture that we want to classify. After training our model, we will start to set up, get information, new information, new profile of vibration. Then, of course, if we took this interval of time, we have this region here that is up to 6. So this image, if get this picture to here, will be classified as a critical. This picture, as it is classified as a critical because there is a region that's higher than 6, and if it is until this point here, it will be classified as moderate. So depends on the stage of the vibration that the picture shows, that will be different classification. And then what is the convolutional neural network do? We input different pictures with moderate profiles. That's this line is between 4 and 6, and different pictures with let's say critical profile. That is the profile, the vibration gets the values higher than 6. And then of course the process of convolutional neural network is define this picture in a matrix, and then these darker points here, when the picture that is go through neural network have no low values of their vectors, say a matrix in this region, so that means their values is around this region here. So that means, and then the algorithm, the convolutional neural network algorithm, will classify this image as moderate. However, if there is some regions that is dark based on this line here, they will classify as a critical. So let's take a look on each layer of convolutional neural network. So the first one, as I already started to discuss in here, is the convolutional layer. So the convolution layer is the first step that translates the picture in a matrix in pixels, and is starting to capture different characteristics of this picture based on the matrix. So the first step, let's take a look on the first step. Consider that we have an input image that that is represented for a matrix 6 by 6. So that is the input picture. So let's say that we have a picture that is represented for this matrix here, 6 by 6. Okay. So then what we're going to do, we use a filter 3x3 in the middle of in the middle of this picture, this figure here, to produce a matrix 4 to 4. So I mentioned that we have a filter. So filter is a smaller matrix. So the objective of this filter is to get different to transform this matrix here in a smaller matrix. Okay, and reinforce the area that have a higher number. So basically, what that is this convolution layer do. So we have, in order to do that, what we're going to do, we go to the third step. That's the input matrix is divided in region 3x3, beginning from the first line to the and the first column. So this is what we see here. We divided this first matrix that represent the whole image in a small image, and then of course the definition of the matrix depends on the algorithm that you're using actually, and the specialists, we are using a small number to be more clear and for you understand how is the process. So let's consider that we've got here 3x3, and of course we multiply two matrices that have the same characteristic. I have let's say I had the filter 3x3, so I got the region 3x3. So the next step is to multiply each cell of the full matrix from the matrix 6x3 by the filter matrix 3x3. So what I'm doing here, I multiply each element from this matrix for this matrix to get the first element for the output. So here we are. I multiply 1, multiply for -1, 0 multiply for 2, 0 multiply for 0, 0 multiply for -2, and add all these values. In the end, I got the first value, that's 2. Then what I'm going to do is to shift one column to the right side. That's what I'm doing here. But let's see what I've got. So here is the first element for the matrix 4 to 4. So as I say, I multiply 1 by -1, 1 by -1, 0 per 2, 0 per 2, 0 per 0, 0 for 0, plus 0 per -2, 0 per -2, and so on. And then I add all this value and I got 2. So then I've got it here. Okay, so I go to the next element. How I define this element? By using the same filter, now I shift this tripartite matrix in one space here to the right side. And then I will go again to the same process, multiply the elements of this new submatrix for my filter. So, and that's what I've got here. So I have 0 multiplied for -1, 0 multiplied for 2, 0 multiplied for 0, plus 1 multiplied for -2, plus 0 multiplied for 1, that's 1, and so on. And then I've got the second element, -1. And then I go to shifting my matrix for more 1 space, and I give this 3, then more 1 space, I get this 3, and then I come back here, go 1 below, get 3 per 3 matrix, go to the right, go 1 below, and go to the right. And then in the end, by doing this process, I will have my output matrix. So what am I going to the output with this output matrix? So that is the pooling layer. So the pooling layer is another filter process, but use the max or min value of the subset matrix or 2 per 2 of the matrix 4 to 4 that comes out the convolutional process. So I've got this matrix here for the convolutional process. So that is the convolutional, the output that I've got from the convolutional process. And then I divide in matrix 2 per 2 in region, 4 different regions, 1, 2, 3, and 4. And now what I'm going to do is to get the maximum value, so I can use that's optional, depends on the algorithm that you have. They use maximum pooling. Maximum pooling means that you get the highest value that I have in here. So I will put in the first element of my output as a matrix 2 by 2. Then I will get the second element of this matrix, that's the highest here in this matrix, that's 2. Then I got the highest element that I have in here, that is 4. Then I got the higher element here, that is 4. Or I can use the mean. So I put the mean average of these values, the mean average of the value here, this mean average of the value here, and the mean average of this value here. So since we want to reinforce to the darker parts of the matrix by these numbers, so the max pooling is more effective in the end. So that pooling layer go through these 5 steps. So as we saw first, we consider the pooling filter as 2 per 2 matrix, and the matrix 4 per 4 will be divided in a subset of 2 per 2 matrix, and each subset will give the value for a final matrix 2 per 2. So that's what we've done here. We divide the output from the convolutional layer, that is the matrix output from the convolutional layer. We divide this matrix in matrix 2 per 2, and then we go to define a new matrix 2 per 2 here. And then how we going to do that? In case of max pooling, the highest value we take, and in case of min, we'll take the max value. So the figures that we had shows the pooling filter process, and the subset of matrix has the element that have a highest highlight in black. So is what you have here. So we have this matrix. Now we are, by using max pooling, we get the maximum value that we have in this matrix, in this one, in here, in this one, and in this one. Okay, this value will take place in the position in the final max pooling matrix. However, it's the mean pool. If you use the mean pooling take place, is considered the mean value. So that's what we do in the right side here. So if I consider the mean pooling, means that I get the mean average of all these values that I have in this matrix, and including here is similar with the others that I'm including here. And then the next step is to shift the green position to a new matrix 2x2 subset. A new matrix has a new matrix 2x2 subset has the elements, and then I will repeat the step 1. So yeah, so what he's saying, they talk only about this first 2x2 region here that will define my max pooling or my min pooling. So after to define this element here, or by maximum value or by mean value, mean average, so I shift for the sides, that is the green sides, so I will get the maximum value or the average. Depends what I have in my algorithm or I choose. So that is the result. Let's say I'm using max pooling. That is result for the pooling layer. So now what I'm going to do, I use the ReLU layer. So the ReLU layer, ReLU means rectified linear units. It's a type of activation functions that get the inputs of pooling layer and produce the output to the full connect layer. So before going to the neural network, we need to classify. And this classification consider the rectified linear units. So basically is use this function here. That's every value that I've got in this matrix will remain the same. Every value that's higher than 0. If I have negative values, they will got 0. So that's what I'm saying here. So if I use the maxi pooling, I will the output of the ReLU is 4, 2, 4, 4, because 4 will always get 4. So that are 3 cases. If I have 2, they will get 2. And I have no negative case. So that was the output of max pooling that we use. Okay, so if you use min pooling, that will be the same. We have no negative, so they will not put 0. So that's what we have here. If we have min pooling, we'll get 1.75, we'll get 1.75, 0.75 you get 0.75, and 1 will get 1. That is the output for the ReLU layer. And now I have the full connect layer. I come back and now I'm after the ReLU, these output values that I have in here is a vector with this value that go through now my neural network. And then I have the common process of neural network that I have waves in here, and in the end I will get 2, depends on the output, I will get 2 outputs or 1 output vector. So, and then the next step is the last step. Now that I'm going to the softmax layer. So consider the max pooling matrix 2x2. The vector will be the one that I defined. So in our case, there will be a vector of this output of the max pooling, and this vector will be the input for the first connect layer. Let's apply the common procedure that you have in neural network, and let's consider the output of the last connect layer like these 2 values. So the output of the last connect layer was 2, as I have 2 output layers, and that means I have also 2 classes. I want to classify my input image in 2 classes. In our case study is or moderate or critical. Okay, so I have this vector here. So what this softmax function do to classify? So basically the softmax use this formula in here, and then by applying this formula using the value of this vector, I have the 20% and 80%, and then this 20% relate the probability to have moderate and 80% the probability to be critical. So in the end, my image that go through the whole convolutional neural network will be classified as critical because it has higher probability to be classified as critical. So that's the whole process of neural network. So our case study is to implement some data sets to train this neural network. So the trained neural network goes from an input image, then go to out convolutional neural network, the pooling, the ReLU. So we have a full connection layer. we have a softmax, and then we have the output classification. Then that is basically what we're going to do first, is to input some image in there to training our convolutional neural network. And then, of course, our convolutional neural network, you can see deploy a graph with the accuracy for the number of interaction. Then, of course, after some interaction, after some training, they get in a very high accuracy and a very low loss function. So, and that's what we achieve. When we achieve that, that means this convolutional neural network is full training, and then we can implement a new data set. So to validate, we come out, it's time to come out with new data set. We can see here we have this picture A that will be introduced and has let's say a low level of a moderate level of degradation, because it's almost 4, but it's between 4 and 6. This second one jumped to 6 here, so it's higher than 6, must be classified as critical. The third one must classify as critical because it's higher than 6 when we get in this point of the picture. And this one, D, also needs to be classified as critical. And then, of course, when we implement our MATLAB algorithm by using the training network that we have, they classify the picture as critical. You can see moderate, critical, and critical. They classify properly all the picture. So this one, for example, is classified as critical. And then, of course, here we can see before the such equipment achieve a high level of degradation, we can do something, because they are concerning now asset management intelligence. They already set up an alarm, and the expert, they can see that. Okay, so now what we're going to do is to use our MATLAB to see how we apply convolutional neural network image classification, and we going to apply the pump bearing vibration image. To do that, we have a very simple algorithm. So the first command will read the image, so we can see the image in the second command. Then we are going to do, we look on the size of the matrix that needs to be a proper size. We format the size, and then after format the size, what we're going to do is to train our network, define our network that we are already training in a applicative, and then based on that we just predict the new data set that we want to implement, and then we've got the result. To training our convolutional neural network that we're going to do as a first, we use the APP that have already the configuration, okay, for convolutional neural network. So let's now move to the practice exercise, and we'll see step by step how we train a convolutional neural network and how we get in the end the classification of our image. So here we are. We're in a MATLAB now. What we are going to do is to open the convolutional neural network application. So we need to come to the neural network, and here is that we have the option of Deep Network Design. You just click in Deep Network Design. Then this template will open here. Here we are. Now we need to select a new blank, and what we're going to do now is to import the file. So now I have a bigger screen, it's much better. So first step is to since we create our database, we come to import our database. And to import our database, we need to choose our file. So here we are looking for the folder that have all our image. So in my folder, you see that I already organized my folder with the pictures that are moderate and critical in terms of vibration limits. So we are going to see that I have this RMS here. So this RMS basically have all the information already images for critical and not critical. And then I will import this database. Now this database with this picture are important to my applicative, and that will enable me to go training my convolutional neural network. So here we are. I have already my data set here, where I import. I'm using that for training this convolutional neural network, and then you can see that I already have the classification of how many pictures I have from each one. Okay, so just let me show this file for you really be sure what me talking about. So if I come to my database here is my RMS. That's RMS means root mean square. This is in vibration. I have critical and moderate. If I have a critical here, I have all these pictures, and then let me open one of them just to show you how does this look like. So this picture is what we call critical, because we have a region that's the level of vibrations higher than 6 millimeter per second, and that's classified as critical. Okay, similar what we have to the other picture. So the other picture have all similar profile. If I come back here, I click another picture, so you can it's come out another picture. So you see different profile, but also in some points it gets in a 6 millimeter per second. So that means when I'm in this timing here. So what I'm saying is that one region of the vibration in this bearing is achieved already, is over than 6 milliliter per second, the vibration here. So that means I will classify as a critical. Okay, so if I go to the template back again and look on all this picture, I'll see the same. Then I have another classification here as moderate. If I click on this picture, for example, I will see levels between 4 and 6. So that is classified as moderate. And then of course, if I go ahead and look other pictures, so this is the other picture, this is another picture, so all of them are in this moderate level. Then of course this picture will help to train the model to classify pictures that are below, have their vibration below the level of 6. Okay, so that's just to be sure that you're understanding the classification. So now we come back to our model. Since I have input the data, what I need to do now is to come for the designer, and then I need to design my convolutional neural network. So on the left side here, I have all the elements, the layers that I use in a neural network. I'm able to put how many convolutional neural networks I wanted, how many ReLU layers I wanted, but I will display here a very simple neural network. So I need to just select, click in here and bring to let's say to this main place in here, workspace, and then of course I have my first picture, and then you can see that is the input, and then I can look here in the right side the characteristics of this information. So one of the important characteristics is input size. So I have a colorful matrix, so I can see here that because we have a tree, so that is a red, green and blue matrix that I have in 27 per 27. So when I perform my validation test, I need to format my picture input in this format, otherwise I will not get the result. Okay, so thus this input layer. So the next one, after I have the input layer, I will create a convolutional neural network, a convolutional layer. So I just push in here, and then I can create the link between these two. Very simple to manage the convolutional neural network. So we create our convolutional neural network from top to the top down. So here we have the size of this convolutional neural network, the information we had here. So we move forwards. Now what we are going to create is a pooling. So we need to look for the pooling here. So here we have average pooling, we have maximum pooling, we have different type of pooling. So we just get, let's say, maximum pooling layer. So here we have a max pooling layer. So we saw, as remember, I said that we also had some, let's say, some two different types of pooling, max and medium. So we're choosing here the max pooling. So here we have the characteristic of our max pooling is matrix 5 to 5. And then what I'm going to do is, after the pooling we have the ReLU. So the ReLU is the first classification that we have. So I just put it, we have different also function here. We can see that's all classification. First I use the ReLU 1. Then of course I come and do the link. So now what I need is a convolutional layer. So remember that I have now, let's say, it's not a convolutional layer. What we need now is the neural network. So we need just to here full connector layer. So that we are looking for. Now we need the full connector layer. Yeah, so here is our neural network. Similar, we do a link. Here we are, and now remember that after the full connector neural network, I will have my softmax function. So here we are, I have a softmax function, and I need to link these two. Very simple. And to end up my neural network, I just put here a classification. So I will link these two. That's a final classification based on the softmax function. Okay. So here are my neural network. The important points that I need to see is here in the convolutional neural network I have two outputs. So have two outputs because I have two classification. Then that will work well. Now my convolutional neural network. Then I go to training. So I will be able to train my neural network, but before training I need to select an option for training. Then I will choose this add-on. That's a good option for training model. We have different type of training models. So I just select one. And then we can go back. So just you need to close here. Okay, then now my network is selected, and then I click here to train my network. So if everything is fine, the logic is complete, all the links is correct, the simulation is started and we will be able to see the result of the simulation. So and then what we're going to see is the performance of the graph. The graph shows the performance of the simulation and how the simulation, along the simulation, how is the accuracy that's the training is trying to achieve based on classification. So we starting here the accuracy of 6-7% we can see, and the loss function is starting at 6, and then that will increase after a period of time. So here we can see increase after 5 interactions. So go a little bit down, now going up again. So and then this process of interaction occur. That means the model are learning to classify this type of image, and then with let's say after 10 interactions, before 15 interactions, the model achieve a high performance and high level of accuracy, and that's enabled us to have a proper model to classify a new data set. Then after we perform this simulation and we are sure that our model is good enough to perform a classification for this type of data, what we're going to do is to import this convolutional neural network for our data space in MATLAB. So here we are. In the end, we achieve 100% of accuracy in this classification. So we had 30 epochs. So epochs, remember the concept that we had in neural network is the complete cycle of training. Then what we're going to do now is to import the training neural network. So now since we exported our function here, we come back to the main screen, and here we are. We have already our convolutional neural network that with training there we export here to a workspace. And now what I'm going to do is to import my new figure. So here we are. I import my new figure, and then now I start to set up the commands in here. So the first command is to read this. So I set up the command here to read the figure 1. Here we are. I have image 1. Now I want to see the image 1. This command here allowed me to check the figure 1, and then we can see this figure 1. We have the level of vibration in a moderate level, so it's above 4 but below 6. Okay, so when you when you run this picture through the convolutional neural network, we expect to have the moderate. Now the next command is to format the figure. Why format the figure? If you look on this figure 1, they have a matrix for 374 and 596. Remember that we had before 227 per 227 per 3. So we need to have the same matrix format. So what I'm doing here is to put the matrix image 1 in the same format, in the format 227, in order to avoid problems when these matrix go through the convolutional neural network. So now I format my matrix in 227, and now the next command is to input the deep neural network, the convolutional neural network in here. So this is the trained network that I've done when I perform in the applicative build the neural network and train it with the data set that I had. And now what I'm going to do is to create a deep neural network to validate this data set that I have. And then the next step is to make the classification of the figure 1, the image 1 that I put here. So I give this command that I call predictor 1, then they classify my image one by using my deep neural network. That is the one that I export from the app. So when I click in here, you see the classification is moderate, so as I expect. So now what I can do is to again use the same command that I have here. So I will create the image 2 and try to classify another picture. So let's do again this exercise. I just put image 2. So I need to import a new figure. Let's say figure 6. So I will click in here, finish. So I have a figure 6 here. I just change here for figure 6. So now my image 2 is equal to figure 6. Okay, so I will want to take a look on the figure 6 to be sure what is the classification. So let's check it out, figure 6. So figure image 2 here, the figure 6 will come out. So now is a critical because the vibration is higher than the 6 mm per second. So this classification of this vibration now supposed to be critical. So let's see what's this classifier. That again, the figure 6 that I call image 2 is I need to format for 227 plus 227. So I use this command here, and I need just to put image 2 here and then image 2 here. Then they will format this image 2 for 227 like image 1. So now here we are, we have image 1, and now what I'm going to do is to perform the neural network. I will bring the neural network. I will call DeepNet2. That's use the same neural network that I was using. So DeepNetwork 2, they both using this training network that I use in app. And now what I'm going to do is to make the second prediction. So I just call second prediction 2, and then image 2. Now I expect to have as a classification the prediction 2. The categorical is critical. So let's check it out. So here we are, category is critical. And then now I have a convolutional neural network. I just need to input this command in here, and then I can verify new pictures based on my convolutional neural network. That's very important to understand that for every different type of picture, you need to collect some pictures, organize in one file, build my convolutional neural network, training this network, and then I export this neural network that I've done in the app. Then I export here, and then I set up this command for new pictures, similar pictures. Okay, and then I can classify this picture properly. So that's the concept behind the convolutional neural network from the very beginning, when we input some pictures and training and create your convolutional neural network, and then by the end when we validate the convolutional neural network by testing new image that we are using. Okay, so now let's go to the conclusion of this model. So the conclusion is the convolutional neural network has some advantages. So ability to turn around image into data classification. We saw that with the example that was given, and then after we have a full understanding by using the exercise, the case study in MATLAB, we saw that, and can be applied to alert level of degradation detected by graphs, image, or equipment defects, and safety as well. So there are different applications all regarding image. So if I have image for defective equipments or unsafe conditions, whatever image that I have, I can train a convolutional neural network model, and then after that I will do the classification. Then of course I can use such methodology and integrate in a asset intelligence management. That's the system starting to give some alerts based on the picture that they get from the field or for a service that are getting information. Okay. However, of course, convolutional neural network have some drawbacks. We saw that the convolutional neural network have a quite complex concept to about how the whole process is, which layer, the convolutional layer, the pooling layer, the ReLU layer, the soft layer, what is the objective of each layer. We need to have a clear understanding. That's why requires a high level artificial intelligence knowledge. It's not so simple. We need to have a good knowledge in artificial intelligence in order to start to perform our training and then classify our image. And complex model to be performed manually, it's necessary an algorithm. Of course, an example that I demonstrated of I went step by step from each layer, but that's let's consider that's a very simple example that I presented in order to facilitate your understanding. But in more complex case, that's a lot of image are coming out, or we need to train the model with thousands of images. That is the usual case. We are not be able to do that manually. So that's important to have an algorithm, a software to do that. And that is sometimes it's cost. You need to invest training, but I do not see as a drawbacks. I see that is a characteristic because it's a complex model. But as we had a chance to see by using MATLAB, for example, you can do that very easy. You don't need to know complex code to do that, okay? So depends on the probability to take a considerable time to simulation. So there's also another characteristic of a convolutional neural network. And for all other models, so depends how much data you're inputting in your algorithm. That's taking longer to train. So and then you need to be careful. You need to have a powerful computer, otherwise you getting frustrated with your simulation. So the convolutional neural network is on my book Artificial Intelligence for Maintenance 4.0 is on chapter 9 of this book, so you can get all this detailed information, the example. I written everything in there, and after the training, if you want to look again and read again, when you want to remember some concept, you can go to my book. Okay, so thanks for your attention. If you have any question, just send me a mail, and let's now move for the last model of the training.